Hello everybody. Um, Today what we're going to be talking about is operations with functions. Um, so you could have things that say like f plus of x. And all that really means is, we're going to take our f of x and we're going to add it to our g of x. Alright, big deal. We could say things that say f minus g of x. All that says is f of x minus g of x. So all I'm taking is my f value, my f of x, my g, and we're subtracting them. Another one is f times g of x. That's just going to be multiplication. F of x times g of x. And the last one you could have is f divided by g of x. And that's just going to say f of x over g of x. Now, I am saying, f divided by g, f times g, f minus g, but really that could they could all get swapped. They could say easily g minus f of x, in which case we would switch it around here. Now, for addition and multiplication, it doesn't really matter since they do follow the commutative property. But for subtraction and division, it does matter what order you work with them. So, if you're looking for composition of functions, that's going to be in the next video I do. But this is going to cover these four in this example. So if I have f of x equals 2x squared plus x minus 3 and g of x equals x minus 1, the first thing that I would like to do is add the two together. So f plus g of x. So what I do here is I'm just going to substitute in f of x and then add g of x. So when I get this, I'm taking my f of x function, so 2x squared plus x minus 3, I'm going to write that down. And then we're going to add the g of x function, the x minus 1. Now, it is a good idea to just get in the habit of always using parentheses, but in case of addition, it doesn't really matter because the parentheses just drop. So now that I've done my substitution, I have everything out that I need right here. Now we just need to combine like terms. So I see my 2x squared. I don't see any x squared terms here. So I'm going to bring that down. So 2x squared. Now I see x and x. I'm going to add those together to get 2 x's. And then negative 3 minus 1, that's going to say minus 4. So this would be my final answer for f plus g of x. Now for our next one, we're going to keep it with those two, same f of x and g of x, but now we're going to switch it over to f minus g of x. So now we do have to be careful about the order that they come in. So first thing I'm going to put in is f of x and then minus g of x. Okay, so f of x we know is going to be 2x squared plus x minus 3. And then our g of x, well, going back, we got to put this in parentheses. Great habit to have. And then going back, we have to put in g of x, which is going to be x minus 1. Now, why are the parentheses so important right here? Well, if I look at it right here, I'm going to have to distribute this minus sign into both of them. So what we do here, we get the 2x squared plus x minus 3. We bring that down. But here, it's not going to say x minus 1. It's going to say minus x plus 1. Because we had to distribute our values in. Alright, but now that we've done that, we have our line here. All we need to do is combine our like terms. So 2x squared, I don't see any other x squareds here. So I'm just going to bring it down. 2x squared. X minus x, well that's 0, so those cancel each other out. and then negative 3 plus 1, so that's going to give us a negative 2. So that would be our final answer for that one. So our next stop is multiplication. So f times g of x. So we're going to read this. We're going to read it f of x. We're going to multiply it times g of x. Alright, so we have this point. But again, don't forget your parentheses when you bring everything down. So we have 2x squared plus x minus 3 times x minus 1. Alright, well, normally what people would think to do is FOIL, but since we don't have a binomial right here, we have a trinomial multiplied by a binomial, FOIL is not really going to help us in this position. So we're just going to distribute a basic distribution, so 2x squared times x, and then 2x squared times negative 1. So 2x squared times x, that gives us 2x to the third power. We add our exponents. And then 2x squared times negative 1, well, that just changes the sign. So minus 2x squared. Now I'm going to take x and multiply it into both of those again. So x times x, that gives us x squared. And then x times negative 1, that gives us minus x. Just switch the sign. So minus 3 times x, our last bit to go. So minus 3x. And then minus 3 times negative 1, so that's going to be a positive 3. So at this point, we just need to combine all of our like terms. So I see 2x cubed, so 2x cubed. Alright, so that one's done. Now I have my x squared term here, my x squared term here. So I have to combine the coefficients. Negative 2 plus 1, that would just say minus x squared. Combine my x terms now, negative x minus 3x, that's going to give us minus 4x, plus 3. I don't have any other terms that I need to combine, so that's going to be my final answer. Alright. Now our next one that we're going to look at is f divided by g. So f divided by g. And this isn't going to be our last one, but we're almost there. F divided by g of x. So we're going to look at this one. We're going to take f of x, and we're going to put it over g of x. We're going to do our substitution. That's what we're doing every time. So 2x squared plus x minus 3 over x minus 1. Now, it's not too clear how we're going to divide these, but the way I like to do it is I like to say, okay, so I see my x minus 1 in my denominator. The only way I can take that out is if I have a factor of x minus 1 in my numerator. So let's just see if I can make a factor out of 2x squared plus x minus 3 using the x minus 1. So off to the side here, I'm going to have this x minus 1. Alright, and I'm going to see if I could factor the top numerator. So I know x times 2x, well, that's going to give me the 2x squared. And in order for me to go from a negative 1 to a negative 3, I have to multiply by a positive 3. So let's check that out. So first, it's going to be 2x squared. Outside, plus 3x. Inside, minus 2x. And then last, minus 3. So 2x squared plus x minus 3. Yeah, that gets us back to where we were right here. So we know that those are going to be factors. So let's just factor it now. X minus 1, and then 2x plus 3. So that's what this becomes. And then we still have it divided by x minus 1. So when I take a look at this, I take a look right here. I see an x minus 1 and an x minus 1. Well, I know anytime I divide a number by the same thing in the numerator and denominator, they're going to cancel each other out. They equal 1. So I'm left with just 2x plus 3. There's nothing else I can combine. That's going to be my final answer. So now let's take a look at g divided by f of x. As I told you, it doesn't really matter. You just have to go in the order that it gives it to you. So g is going to be x. So g of x now divided by f of x now. So g of x is going to be x minus 1 over f of x, which is 2x squared plus x minus 3. Well, again, I see a factor up here, the x minus 1. How can I use it? Well, I already know the factors from my last problem for 2x squared plus x minus 3. So I'm just going to reuse those. I know I'm going to have them again. So I'm going to have the x minus 1 over, well, again, it's going to say x minus 1 times 2x plus 3. Those are the factors that we had from our last problem, and they worked out just fine. But again, I see my x minus 1 here and my x minus 1. They cancel each other out. But what's left? Something is left. Because I can't just write, 2x plus 3. I know I don't have a 0 right here because that would be 0. What I need to write is I'm still left with something in my numerator, and that something is a 1. And so this would be our final answer for g over f of x. So coming to the next video, we're going to be working with the same thing, but we're going to stop here, and we're going to, in the next video, learn how to check our answers on the calculator. So tune in for that to see how you can use the standard calculator to check your answer.